Okay, for this video, I'll be demonstrating how to again make use of file IO in C language, and at the same time an array of structure. So this is actually a revised version of a solution in my previous videos. So let me now explain the source code. So what I have here is a structure containing the following fields. So that number, name, course, total fee, and total payments. And then I created a structure with a maximum record of 100, or it's an array of structure. So I call it STRUCT. And then to keep track of how many elements are there inside this array, I have this variable which I call the number of records. So initially it should be 0. And then I have here some of the functions, or my user-defined functions that I'll be using for this program. So I have CLS, which will clear my screen, pause, which will pause until a key is pressed, menu, which will display the main options of this program. And then we have load records, which will actually read from a data file, and then insert this data into our strct array or strct array. And then we can also enter records, and these records will be saved into the data file. We can sort the records and also save the changes to the data file. We can search record, and then we can display also a single record, which will be part of my search record. And then we can display a balance rep. And then here I have here we can get the fields, so from a particular record. So I'll be explaining more of this as I go on. So here's now our main program. So in our main program, once we open the program, it will load the records from my data file into the array, and then it will display the menu, so inside the loop, and of course it will get the user response from that menu. And then depending on the user response, we have to process these responses. So for example, if the user pressed E, we enter records. If we press F, search a record, S to sort, B to display the balance report, and Q of course is to quit. So we keep on doing this until the time that the user quits the program. So let's now take a look at the specific functions. So first we have our clear screen. So it will just call the system command with the CLS. Pause is to print just a prompt, and then get ch. Then menu will display our options. We have here E to enter records, F to find records, S to sort the records, B balance report, Q to quit the program. So this is just displayed, and then we get the user response. So and converted that to uppercase. So that will be returned by this function. Then we have here the load records. So in my load records, we open a file. So we declare a file pointer, and then fp, so the file pointer is equal to fopen. Then this is the name of our data file, data point dot, and then for reading. So we're going to read what is inside this data file. Here I made an assumption that a line can have a maximum length of 1024. Of course, we can add more to this. It depends on the length of your data, but for me this will be enough. So the number of records now is equal to I here, an integer. My loop control variable is equal to the number of records minus 1. So initially this is 0, so this will start with -1, which means this will be actually also my pointer for my array. So here I read one line. So fgets will read one line with a maximum length of 1024 from my fp stream. So this will read one line in our data. So I'll show you. This is our data. So this one is one line. So the computer will read one line. So this will read one line, and then after one line is read, then we add 1 to our number of records. So from 0 it becomes 1, and we also add 1 to our array pointer. So that means from -1 it becomes 0. Again, because an array, the index of an array starts with 0. So get fields line 1. I'll explain get fields later. So this one will, the get fields, just a bird's eye view of this function, this will separate each item. So you notice here, this is one line, and we have here several data in that particular line. So to get each item here, its token, then we use the get fields function. So that is just a user-defined function. I'll be explaining that later. Again, so if you want to get the individual data or the fields here, so we use the get fields function. So let's go back. So we do that until the time that we this returns null. That means we have read all of the records in our data file. So after reading the records in our data file, we just close. So that this will read and then place this the data in our STRUCT array. I will explain that again. I will be going back to get fields later again. And then enter records. So I open here another file pointer. This time around I use A for append. That means that each time we add a record or we enter a record, the record will be added or appended to our data file. So here I is now equal to the number of records. That means I is pointing to the next record, because again I starts with 0 or my index. So the next will be equivalent to the number of records. So char ch is equal to y, then while ch is equal to n. So while we have answered no, what we'll be doing here is to display the prompt, and then enter each record. So first we have student number. So this, we have here the dummy, just to make sure that our display will not be messed up. And then enter name. So we enter name, we enter course here. So we enter the course of the student, then we enter total fee, and then we have here total payments. So after we enter the data, we just write the data to our stream or our file stream or file pointer. So fprintf, so just like printf, but this one is we have here f, a prefix f. It means we're writing to a file or file stream or an output stream. So we have here fp. So the same, we have here integer, then comma, because our data is separated by comma. As you have seen here, each data is separated by comma. So here also we separate each item with comma. So we have integer, that's student number, string for student name, string for course, and then float for total fee, and then another float for total payments. So this is now writing it to the file. Printf more. If we answer yes, then it will again loop. So we enter another set of data placed on the next index of the array. So while we're entering data also, we add to the number of records. So once we're through entering data, we close our file pointer. Again, each data that we enter will be appended. That's why we place here A. And then sort. So we have here our bubble sort. So while swapping, we just, so while they're swapping, we continue doing this. So first is we set our flag swap to 0, and then we loop from 0 to the number of records minus 1, or the second to the last record, then compare the first or the current record with the next record. That's why we have here I plus 1. Then it should be, so the student number should be from lowest to highest. So if the first one is higher than the next one, then that means their sequence is not correct. So therefore we swap their places. So this will swap the places of my record. Then since swapping was done, I'll place here swap is equal to 1. And then again, after that, since swapping is equal to 1, we keep on doing this until the time that the program will not pass to this into this place or into this code, and swap will not be changed to from 0 to 1. That means that the array is already sorted. So once the array is already sorted, it will print sorting is done, and then it will prompt the user now to answer this question. Do you want to change do you want to save changes to the file? So once you answer yes, if the user answered yes, then we open a file pointer. We open a file for writing, so it could also be just W. So we're going to overwrite the file, and then we loop from 1 to the number of records, 0 to lesser than number of records, because again our array starts with 0. And then we just write the file again, just similar with the previous one. So fprintf, we have fp here, our file pointer, then we have decimal or integer, string, float. So here we have decimal, then string, float. So it corresponds with this, separated by comma. And this one is just to know if, or just some sort of feedback that it is processing our writing of data. Then at the end, it will print records, save, and then close the file. This one is optional. You can remove this if you want. So after that, we can also search record using linear search. So we just ask for the student number. So enter the student number, and then we use linear search. It returns the position. If the position is greater or equal to 0, that means the search was successful. Then we display that record. Otherwise, we just display the student number was not found inside the array. Then we have here linear search. So integer found equals 0, integer I equals 0. So while not found and I is lesser or equal to number of records minus 1. Okay, so minus 1 because the array pointer is from 0. So this one is higher than the last index of the array by 1. So while not found and I is lesser or equal to number of records minus 1, so we just compared student number with the number we entered. If they are equal, then found equals 1. If not, go to the next record. So it will go out once it is found or I exceeds this value. So we just test if found, then return the position I. If not, we return -1 to indicate that the search was not successful. Then to display the records, a single record, so we have here the record number. So we just use that as the index of our array, then retrieving each field from our structure. Of course, using the appropriate format. So we have integer, string, and then float here. So that will display a single record. And then we have the balance report. So for the balance report, we just traverse from 0 to the number of records. So lesser because, again, this one is higher than our last index. So next here we have our accumulators and other variables. So we have our title. We just print our column headings. So student number, space student name, so left align, course is left align, total fee is right align, so we don't have the negative value. Total payments or payments is also left align, and balance is also left align. Then we traverse from 0 to the number of records minus 1, or 1. Yes, number of records minus 1, or number of records, because we use here lesser. So we compute for balance is equal to total fee minus total payments. Then that overall total fee, so T total fee is plus equal to total fee. So we just accumulate for the value of total fee and total payments, and also for balance. So the three are similar. We just accumulate the value of total fee, total payments, and balance. Then here we now display the values of our detail line. So we have student number, student name, course, then we have total fee, total payments, and then the last one is for balance. So once we are through printing the data lines, we print the footer. So we have three totals. And then this one is for total fee, or the overall total fee, overall total payments, and then overall balance, and then we post. Now here we have the get fields. So in our get fields, we have this function strtok here. This is to get a token from a string. So what we did here is we get a token and we use the comma as our separator. So this will get the first item in our line. So if this is our line, it will get the first item before the comma. So here it will be equal to our student number. So just convert that, because it is a string. Notice it is a character or a string. We convert that into an integer using atoi function, array to integer. So that will be converted to an integer and then stored in our record. And then get the next one. So to get the next one, we just use token equals to strtok null gamma. So that will get the next item from our line here, and then place that item in student name. Now to copy an array, we use strcpy. So that will, because these strings are actually array of characters, so this will copy this to this array. Then again, get the next item. So that will be the third item. It is actually course, and then copy the item or the token to course. So again, using strcpy, then get the next token again, and the next token will be actually of a float format. So we convert that array into a float format. So we use a to f token, and then stored in total fee. Then get the next token. This will be our last token for our record. Convert that again to float, and then we have the total payment. So that is how we get each record. So we just use the strtok function. Okay, so that is basically the source code of this program. So let's try to run the program, compile and run. So let's display the balance report. So this will actually load the data from our text file. So this is the data that was read by our program. Okay, so let's try to add. Let's press any key. Let's add more records. So I'll press E. So for example, 109. Okay, so more, let's enter one more data. Let's say 125. Okay, then I'll place here no, press N key. Now if you're going to check the data file, it says here this file has been modified by another program. Do you want to reload it? Yes. So let's reload this file. So you notice that the data I have entered is now inside my data file. So I just open it using Notepad++. So let's go back. So balance report to check. So there we have here our two records. If I find record, let's say 222. Do I have 222? Oh no. So find records. I think I have 113. So I have 113. And then let's sort the records. So I'll press S. So they want to save the changes to the file. So I can write the changes to the file so that also my data file will be sorted. So let's say no first. Then I'll click on balance report. So it is now sorted according to student number. So let's sort again. Then save changes to file. I'll just say yes now. No. You notice if I go to this data file, it will not ask me to reload because it is not yet changed. So let's go back to the program. Do you want to save changes? I'll answer yes. So here's my feedback. So balance report still sorted. I'll go back to my notepad. It says here now that it is modified by another program. So do you want to reload? Yes. So you notice now it is sorted according to student number. Okay, so that is now the program. So in a way, I have explained the functions. Again, I'll be placing a link for you to be able to download the source code of this program. So thank you very much for viewing this video.